Hello, welcome to Engineers Ireland and the Junior Cert Honours Maths Grinds. Today we're going to look at something that I know that a lot of students don't particularly like, but it's quite easy, and it's quite easy to get good marks in the exam, so it's well worth your time paying attention to the graphing of functions. Now, this is one of the sections that I know is very well covered in schools, and you'd be well used to having lots of home exercises and things in it, but it's still worthwhile having a look at it and just getting an understanding how it fits in with geometry and with algebra. So the first and obvious type of function that you're going to deal with will be a straight line. But even before we get on to that, let's just distinguish between two things. For example, if we have y being this function here, and remember f is only the first letter of function, so we're saying y is a function that's depending on the value of x, and we're saying it'll be this one here. Now you can obviously have a constant in here. It could be -6 for argument's sake. You don't have to have a constant. Now what you have to notice is this thing is a function, but that's an equation. I know we've touched on this before. Equates. The left side equates to the right hand side, and as it turns out the right hand side is 0. You'll notice that all these bits are the same as the bits you have here. But in the equation down here, we're saying that we're only looking for values of x that will balance this equation, where you will finish up with 0 equal to 0. This thing up here, this guy, this function of y, can have lots of different values, and it'll be totally dependent on whatever x value you pick. So understand that a function isn't the same thing as an equation, even though the algebraic bits, the x squareds and things like that, may be exactly the same. The simplest type of function that we deal with is the one that you will be blue in the face looking at. It's the straight line, and we will say that y is this function of x, and y will get plotted along here, and x gets plotted along here. Whatever the equation, for example, if we had the easiest way to deal with straight lines is to convert them into this version, y equal to some number multiplying the x plus a constant. The reason for it is it's going to cross the y-axis at that constant value, whatever this one is here. And whatever number is multiplying into the x is the slope. So in this case down here, we know it will cross the y-axis at 7, and the slope of it is 2. So for every single step we would take, try and draw it here, if we're on the graph, and if we take one step in the direction of x increasing, the y will have increased by 2. So that's the slope of 2. These are quite easy to graph, because already you can see that the free number, when you put the equation in this form, that the free number is always where it crosses the y-axis. Now, where does it cross the x-axis? Well, now hunting for that point. If you think about it, there's a certain y value here, another y value here, and lots of different places down here. Right down here, y is 0. And anywhere along the x-axis, anywhere, y is 0. So the equation of the x-axis is y equals 0. And just so that you're clear on it, anywhere along the y-axis, x is 0, because after all, it crosses. You've got the origin in the middle. So the equation of the y-axis is x equals 0. Now, we're hunting. And what we're hunting for is that point here. We know at that point that the y value of the function will be 0. So we're going to find a particular example of this. For example, taking the example we're using here, we're going to find a particular one where y is equal to 0. And what we would do then is we would say, okay, 2x plus 7 equals 0. So if we're assuming this graph that we have up there belongs to the one that we have, that we're discussing here, we will be saying that that's plus 7. See? There. And this is minus 7 over 2. That value. For a straight line, you actually only need 2 points. Now sometimes they're very smart. They'll give you a line where your 2 points are going to be so close together that drawing a straight line through them could give you wrong answers off up here somewhere and off down here. So to find your graph and accurately draw it, they normally give you a range, and they'll say in the range where, let's say, minus 2 is less than or equal to x less than or equal to 4. Well, there's no harm picking the extreme ends of the range. Put into your equation here, put in x equal to minus 2, find the y value, put x equal to 4, find the y value, and then you plot. It's an easy one. But the principles are exactly the same as the ones that you would apply for quadratic equations. So let's look at those. And as usual, y is the name that we're giving to this function, and that function will be in the form of some constant x squared plus some constant x plus a constant. Look at the free number. What we know is along this y-axis here, that x is 0. So if I put x equal to 0 in here and in here, those two terms go to 0 and y will be equal to the c. So in this case, you can recognize that the c would be there. So for a linear equation, a quadratic equation, a cubic equation, or any of these polynomials, when you set it up as y equal to, and everything on the right hand side then related to x, the free number, the one that doesn't have any form of x or x to a power multiplied into it, is always where it crosses the y-axis. So that's always an easy point to find. Now, very often, but not always, there are two locations where a quadratic will cross the x-axis. Remember, we know the x-axis has an equation. It's y equal to 0. So we're going to set up y equal to 0. When does that happen? When ax squared plus bx plus c is equal to 0. So we've set up our equation again. How do we know it? That equals that. Why? Because when y is 0, we can look up here and see when that's 0, then all of this is 0. And that's all we've written down here, that this thing is equal to 0. And you are dealing with something that you've been looking at for at least 2 years. So that's not a bad thing. You will definitely get the marks associated with finding that point and that point. If, for argument's sake, we are looking at on the x-axis y equals 0, that implies x squared minus 5x 5 plus 6 equals 0. And if you can, you factorize. We know it's just an x because it's just a single x here. Now this plus, sorry, I will change my equation if you don't mind. I will change it like that. That minus then, what does it tell us? It tells us that one of the numbers that we're going to be putting in here and here, one is positive and one is negative. So we can write that much in, a negative one and a positive one. What does that minus tell us? That minus tells us that when we add the two numbers together, that the minus one is the biggest. And we're looking for factors of 6. So 1 multiplied by 6. And the minus 1 is the biggest. Those two, one multiplied by the other, is equal to 0. So we can say that implies x equals 6 or x equals minus 1. We would then be saying that the x value here is minus 1 and the x value here is plus 6. So we've now got 3 points. One point that they like you to find, and sometimes they're very easy going on you because they give you a location where in this case the minimum, we'll just say it's there, that the minimum of the graph is at a nice easy number like x equals 2 or x equals 3. Now I've chosen one where that won't be the case. So let's now look at something. That's one type of quadratic, and we'll talk about these in a second. And here's the other type of quadratic. And yes, it crosses the x-axis here and here the same way as this one crosses there and there. We're looking for where is, in this case, the minimum. How do we find it? What x value? X equal to what? And in this case, where is the maximum? X equal to question mark. Well, the nice thing about it is it's always halfway between these two. It's halfway between where it crosses the x-axis. That's where you'll find the peak. So in our example over here, we have minus 1 and we have plus 6. If we add those together, so when in this case over here, when x is 2.5, we will get the minimum value. And all we've got to do in the equation is say y then is equal to 5 over 2 squared minus 5 by 5 over 2 minus 6. And that will give us the y value, and we'll know the point. Now, that's not particularly hard. As I've mentioned, that's halfway between these two. Now let's just step across into stuff that we've covered already, which is dealing with the quadratic equation and the solution to the quadratic equation, and we'll see how all this ties back in. The general form of the quadratic equation is a x squared plus bx plus c. And because it's an equation, we're dealing with this. We know when that is the case, that then implies that x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Let's just go over here and we will just look to see what kind of an equation we have. We have x equals something plus or minus something else divided by another item. That's a bit like saying 2 plus 3 over 7, for argument's sake. We'd say, that is 2 over 7 plus 3 over 7. In other words, it's the first something divided by what was underneath. And in this case, watch, so it must be plus or minus the second thing divided by the thing underneath. If we can see that over here, then we can apply what we know to the maths that we're dealing with. We're saying, so then x is equal to minus b over 2a plus or minus that means our two roots have a common bit. They'll both have that, and they're going to be plus or minus so much. See? If we just draw this, not good. X-axis. One root is here, the other root is here. Halfway between both of those, what's the x value? X is equal to minus b over 2a. So right in the middle, between the two roots, where the equation, or sorry, where the function crosses the x-axis, right in the middle, we'll give you the x value that in this case would give you the minimum. And if we had a function that ran this way, we would find where the maximum is. So then, you've now found a new way of finding the location of the minimum or the maximum for a quadratic equation. Whatever the equation, and we'll say, to pick the one that we had before, x squared minus 5x minus 6. That makes a equal to 1, see? B is minus 5, and c, which we don't need to find the middle bit. So we get x is equal to minus, outside of minus 5, all over 2 by 1. And if you notice, that's the exact same answer we got on the previous page. So what you need to remember now is a very simple equation. at the max, or sorry, to find the maximum. Or minimum. Use x equals minus b over 2a. The nice thing about that is this is one of those equations, the solution of the quadratic equation is one of those few equations that almost everybody seems to learn in school. So you just have to remember the first half of it, and that'll give you the x value, and you put it into your equation, whatever quadratic you're using, and that'll give you the y value, and then you will know the value of this. Before we move on, let's just consider if the middle is the minus b over 2a, this one here, x equal to minus b over 2a. Look at what we have here. We're saying that middle bit plus or minus an exact same amount. We're going to add and subtract the same amount. So now what do we know? This bit is plus and this bit is minus. So we find that all along when we were using this equation here for the last 2 years, that what we were really finding was the middle point plus a bit to give us that one, and minus the same amount to give us that one. There are a few names that you need to know now. And I've deliberately put a capital on the D here to show you that it's a very similar word to that one. And this is just straight out of one of your textbooks. Now, when we look at these numbers, it's very clear what the function is. Y is equal to x squared. That can be written in a number of different ways. We can say any x value that's in our domain, and think of domain a bit like if you were a prince or princess. You would be a prince or princess over a certain domain. This is my domain. I have authority over this. So your starting numbers are the ones that you get to use. They're the things you get to plug into your equation, okay? They're the things you get to slot in here. You have total charge over the ones you drop into the function. That's your domain. You have authority over them. You can order them, right? X equal to 4, put it in here, and we'll get an answer. Now, the range is the set of solutions, okay, to all of that. So if we have those two, then why do we need a codomain? And you have to listen always when you're dealing with your mathematics. You always have to listen to the language that you're using. In our case, we're using English. But whatever language you're using, listen to the words of the language, because that's what tells it to you. In this case here, it says the set of output numbers, and in that case 1, 4, 9, 16 x squared, it's called the range. It's pretty obvious, isn't it? Well, what's a codomain? It's the set of allowable outcomes. Let's look at one. This is going to be a domain again, and this is going to be a codomain. And for the moment, I won't bother putting names on these and tell you what the numbers are. All that matters is that this guy, this codomain, it contains all of the solutions, that guy, and that guy. Now it also contains, as you notice, extra ones. Those extra ones are the only other possible solutions that you are allowed. So the codomain contains the range and the remaining allowable answers that you can have. There are two particular cases that you have to watch for, because one is going to be a proper function and the other one is not a function, and these are very well described in the textbooks. That's the first one. Both of those drawings show something being mapped across. Watch it getting mapped across to a point in the second set. Now the difference is, in this case 1, B, this lad, has found that it can map to two numbers on the other side, 2 and 3. So if something in the domain can get mapped to more than one thing over here, what we're looking at here, what this drawing is talking about, is not a function of the type that you guys are going to be dealing with, because each thing in the domain can only be mapped to one thing in the range or codomain. You cannot have the possibility that you'll get two answers out of this. So, not a function. Look at the second case. Each thing in the domain has actually got mapped to something in the codomain, or in this case it's a codomain because there are leftover bits. Now f and g both got mapped to 8. Is that a problem? The answer is no, it's not a problem, okay? So this is a function. I'll rewrite that. This is a function. So what's the not allowed thing? The rule is that each item that's in the domain can only get mapped to one item in a codomain or range, and it makes no difference if it happens to be the same number over here that some other number got mapped to. That isn't an issue, but the first one is an issue. We have two types of functions now that we have to look at in relation to quadratics, and we've already discussed them. How do we distinguish between them? Because both of these have this form. Y is some function of x in this form, a constant multiplying into the x squared plus a constant multiplying into an x plus a free constant. So which is which? Well, for this guy here, A is positive. For this guy here, A is negative. We'll give an example. In this case here, y is equal to, and we can write it in a number of different ways. Yeah, we'll pick this one. You can write it minus x squared plus x plus 2. But usually it is written as y equals 2 plus x minus x squared, so that you'll normally see the x squared term with its minus towards the end of the function. And we're all very familiar with these ones up here, the ones over on the right hand side, these ones that have a minimum value. They're like the one that we dealt with earlier. And you will notice that the x squared has a positive number plus 1 multiplying into it. So the first thing you notice before you go to graph these things is that you have plus or a minus in front of your x squared, because that will tell you if it's a plus it's going to look like this, if it's minus it's going to look like that. Now I just want to go through one little thing with you here because it's important, because this could possibly confuse you. If we look at this one, and we're now going to look for, well, it's going to be easy to find where it crosses the x-axis, for example. We already know where it's going to cross the y-axis. See, +2. And we're now looking for these 2 points where it crosses the x. We know on the x-axis y is 0. So we will say, well, by the way, whether you use it this way or this way doesn't make any difference. So we will say 2 plus x minus x squared equals 0. We're now, as we said, hunting for this and this location. The first thing we normally do is we pull everything over so that we'll say that implies x squared minus x minus 2 equals 0. We very easily consider that both of these are exactly the same. And the interesting thing is they are not. If we go to solve this problem, a single x on both sides because there's only this out here. This tells us one is positive and one is negative. This tells us the negative one is the bigger one, and we're looking for factors of 2. So we're saying and we're quite pleased with ourselves. -1 and 2. They are the right values. Now, why I'm saying you need to be careful about judging this as being exactly the same as this one comes down to trying to work out the peak. We know that it's going to occur halfway between our 2 roots. So we could quite easily do this. Say that x is going to be equal to 2 minus -1. Is that correct? Come on. We're adding them, right? So it's 2 plus -1 over 2, and we expect to get what out of this? Down on the basic little level of even simply adding 2 little numbers, it's awful easy to make a mistake. So we're saying when x is a half, we're going to get the peak value. So let's put x equal to a half in here. A half squared minus a half minus 2 equals 0. That implies 1 over 4 minus a half minus 2 equals 0. Okay. Now, what is it that we're dealing with? We're dealing with a value up here, aren't we? We're not dealing with the values down here. So we shouldn't be dealing with the 0 bit here. We are looking for the y bit. Y equals. We're looking for some other point. So we're now saying that implies when we add these together, -2 minus a half is -2 and a half plus a quarter. We're saying, oh, the y value then is -2 and a quarter. Now that's a positive value. Look at it, it's up here. So be very careful when you're dealing with these ones that have a negative a on them. Be extremely careful, because as a matter of almost reflex after 2 years of playing around with them, we have a habit of, when we're looking for our roots, to put them into this form, and then we're looking for the peak value or the trough value, and then you go along and you say, find the x. Yes, we did that. And then we put it into the wrong equation. We put it into this one. Now, in reality, it will be the opposite to this. The important thing is, having found x equal to a half, you put it into your original equation. So what was it that we were dealing with when we found the reverse of it? This guy. What were we dealing with? It was basically this guy. It's mirror image. Now, you're going to have to bear with my poor art here. That function is y equal to x squared minus x minus 2. You can reflect the first function in the x-axis, and we will find exactly the same roots, and this is exactly as far down as this one is up, and they occur at the same location. Now, don't worry too much about this. The whole issue is you don't have to think in terms of this if you always go back to your original equation. Okay? Now the next thing that you need to know, and you've almost gotten to the end of all this already, we will go from, yeah, we'll do this bit. Two graphs. Most of the time you're going to be dealing with some quadratic, and you'll be dealing with a straight line, which doesn't have to run up the way, it may run down the way. We've already learnt how to find that for the straight line, that for the straight line, and any other x values such as this one here will tell us that point when we plug it in. So there's no problem with those. We've already worked out how to find that point, this one's easy. All that's obvious. What we're looking for now is that point and that point. Where do they intersect? We can understand this if we pick some point clearly where they do not intersect, and we'll come over here. For this particular x value over here, when I put it into the quadratic function, what sort of an answer will I get? I'll get this answer. But when I put it into the linear function, the line, I'll get that y value. Now it's very clear that the two y answers are not the same. Where the two functions meet there and there, they're the only 2 points where an x value gives you the same y answer, and that's the secret. We'll just look at this. We're going to call this one f at x, and we'll call this one g at x. Y is the answer that comes from the function with when x gets put into it, and the function is x squared plus x minus 6. We also get a y answer from the linear function, what we've agreed is that where the two join, the y's are the same. We'll get that y exactly the same as that y. Because this y is equal to this, and this y is equal to that, that means at those 2 points where they meet, f of x will be equal to g of x. The two functions have the same y answer. So and we can go and solve. One is negative, one is positive. The negative one is the biggest one, and they are factors of 3. And all we have to do in any of the equations, and you always pick the easiest equation, you put in the x values, and in this case the easy equation is the linear one. You put x equal to 3 in here. 3 3s are 9, minus 3 is 6. And we put in minus 1. 3 by minus 1 is minus 3, minus 3 minus 3 would give us our other one. Now, that's not difficult. You can easily reason your way through all of this. Just so that we are clear on the little point I made earlier, let's find the minimum here on f of x. This is a little recap. We know for this quadratic equation that x equals minus b over 2a is the value that gives a max or minimum. So let's deal with that one up here. So it's going to be x is equal to minus 1 all over 2 by 1. So in our case here, when x is a half or minus a half, we can put it into this and it'll give us our y value, and it'll tell us what value the minimum is. What else do we need to know? And basically there isn't much more. Normally, when we draw a graph, or when we're given a graph, and we will just go again for something simple. Minus 2 here, so that's minus 2, and we're asked the question, when is the graph negative, or when is this function negative? When will it give y values that are negative? Now we can clearly see them, they're down here, they're not the ones up here. So we're going to say that it'll be going from here to here, those x values will give us any value in here will give us a negative answer. That clearly means that we're going to hunt for the two extreme values, which are the two roots of our quadratic. Minus means a negative and a positive. The positive, this being positive means that the positive one is bigger than the negative one. And we're dealing with factors of this. Now what does negative mean? That's the next question. Is 0 negative? Would we say that minus 2 is less than or equal to x, which would be less than or equal to plus 2? What we're really discussing, sorry about that. What we're really discussing is, should we put in an equals in this? Is 0 negative? Well, the ways I normally think about these things is I go back to the number sets. Natural numbers, n, are 1, 2, 3, and on and on and on. All these nice big whole numbers. In 0 includes the 0. The Z set I always think in terms of what is it that the Z set adds in. It adds in all of these guys. It doesn't add in the 0. So for me, the solution to our problem here is negative doesn't mean 0. We would be taking away this. And when we're drawing it on our graph, and assume that we're using the red to draw the range, we will use an open circle on these. That range of x values gives you negative values in your y. In general, you're expected to be systematic in how you do your how you come up with your graph. If they say to you that they want you to deal with y, the other name for this function, and we're asked to look at it in the range from minus 2 less than or equal to x less than or equal to plus 4. Normally what you're supposed to do here is set up a table. And we have x equal to, and you'll go minus 2, minus 1, 0, 1, 2, 3, 4. It's very easy to be a hero and do the whole equation out in one line. Why? The easiest thing is to deal with the equation in a systematic manner. We have a 2. That's the first bit. You have a plus x. So you're just going to add the x values now. So that's plus x. And now we're going to look at the last bit. So x. Here it's minus 2. Minus 2 by minus 2 is 4. But we want minus the answer. Minus 1 by minus 1 is 1, but we want the minus answer. 0 gives you a 0. 1 squared gives us a 1, but we want the minus, etc. And then you total them. This one, when x is 0, was always known to you. It's the free number, the one that doesn't have an x or an x squared or anything in it. That's always where it hits the y-axis, if you remember. And the rest is just an addition thing. 2 minus 1 gives us nothing. 2 plus 1 is 3 minus 1 gives us 2. And you fill in all the others. Normally, when you fill those in, if they ask a suitable, interesting function, you will find that you won't exactly have where it crosses the axes, or the point where you get a maximum or the minimum. Let's watch again. Max or min. Y is equal to minus b all over 2a. And we are looking at it up here. Minus b, it's minus 1 all over 2 and minus 1. Is that correct? Now, always watch for making silly mistakes. In an exam, we lose 15%, for example. You can lose of marks that you should have by making silly mistakes. We do know that our quadratic equation, our generative form, is ax squared plus bx plus c equal to 0, and in that circumstance, where we are looking at the equation where it's hitting the x-axis, now we can go and look at x equal to minus b plus or minus. So this is the first bit of that equation, remember? It's the common bit. And that common bit tells us that when x is equal to a half, we will get the biggest or the smallest part from this function. Do you notice how we have a negative in front of the x squared? How is that going to work? It has to have this kind of a shape on it. So when we put in x equal to a half, we will find the biggest one. The principles that you have looked at here can be applied to any of the type of functions that you would have gotten in algebra. Even if you were asked a cubic, you would work out your table. You're told a range from, for example, -2 to 4, and you do out each of the parts of the cubic equation and you add them up like we've just seen. So there's no need to worry. Cubics, just in case you're interested, they will look either like this or they will look like that. That's just a curiosity point for you. Well, that's as much as you need to cover on this. What we'll do the next day is we'll go through past questions, covering the parts that deal with graphs. They have a habit of coming up in 2 questions in paper 1. They don't always come up in 2, but once you take your time over them, they're marks that you can be pretty confident about. So until the next day, goodbye from Engineers Ireland.